Hello, welcome to today's class. Lesson number lesson number 6 of module number 1. Before we start with today's class, let us see what was done in the. Let us do a quick revision of what was done in the previous class. In the previous class, we learnt about the various obstacles that a surveyor can come across in a while doing chain surveying, and those obstacles are categorized into three groups. Okay. Uh, in the first group, there are obstacles to only ranging. That means you cannot see from the first point to the last point. Both the points are not intervisible. An example is when you are surveying across a forest. Okay. Next category is obstacle to chaining. That is, you cannot measure the distance from first point to the last point. An example is lake. You cannot measure distance from one end of the lake to the other end of the lake. So there is an obstacle to chaining or taping. Next, and the third type of obstacle is obstacle to both ranging and chaining. Now here an ideal example of this case is a building. If two persons standing across, if you are surveying and you come across a building, you cannot see from one side of the building to the other side of the building, and also you cannot directly measure the length from one side of the building to other side of the building. So building is a perfect example of obstacle to both ranging and chaining. Next, we'll start today's class. Okay, in today's class we'll be learning about two topics. First one is ranging of lines, and in ranging of lines there are two methods: direct ranging and indirect ranging. And the next topic is electronic distance measurement, and what is the basic principle of electronic distance measurement. Now ranging of lines is done when you want to establish survey lines, especially when the length of the survey line is more than that of length of the tape. And electronic distance measurement, in almost all the modern instruments electronic distance measurement is used. And it is the fastest way of measuring between one point to from one point to another point, especially when the distances to be measured are very large. It saves a lot of time. Many modern instruments such as total station, it is equipped with this technology, and also electronic theodolites are also equipped with electronic distance measurement. So we'll see what is the basic principle of electronic distance measurement. So from the optics, that is from the physics, we have this formula: V is equal to F multiplied by lambda. Now V is velocity of the electromagnetic wave, in vacuum, this velocity will be equal to velocity of light, and it is written in terms of meter per second. Next, lambda is the wavelength of the electromagnetic wave, and it is measured from this point to this point. This is the wave length, and it is written in terms of meters. Frequency is f is the frequency of the electromagnetic wave, and it is measured in terms of hertz. Hertz is nothing but per second. So how many cycles of waves are emitted per second? Or you can even use this formula: velocity is c divided by n, if you want to find the velocity of the electromagnetic wave. Say okay, v is the velocity of electromagnetic wave which you want to find. C is the speed of light in the vacuum. We know its value, it is a constant, and n is atmospheric index of refraction. Its value depends on the atmospheric in the atmosphere, or in the atmospheric conditions we are conducting the survey. So if you want to find the velocity of the electromagnetic wave, we can use this formula. Next, now how to measure the distance between 2 points. So there are many methods. There are two methods by which we can measure the distance between 2 points using an electronic distance measurement technique. Okay, now to measure the distance between 2 points, you need the EDM device and a reflector. Now in the first method, we are measuring, we know the speed of light, and we are measuring the time taken by the electromagnetic pulse emitted from the electromagnetic device to hit the reflector and come back to the electromagnetic device. So it uses a simple technique of velocity is given by distance divided by time. So distance will be equal to velocity multiplied by time. So distance is equal to velocity c multiplied by time. Now time is taken as t by 2 because we are measuring the time taken by the pulse traveled from the device to the reflector and back again to the device. So the pulse is traveling the distance twice. Hence the time taken by the pulse to travel the distance one time will be equal to t by 2. We are measuring the distance, we are measuring the time traveled by the pulse to travel the distance two times. So time will be taken as t by 2. The next the next method is phase measurement. Here we can measure the number of wavelengths from starting point to the end point, that is the number of wavelength from the electronic distance measurement device to the reflector. So you can measure the number of wavelengths. So n is number of wavelength and lambda is one wavelength. Okay, and L is the length of the line or the distance. So by measuring number of wavelength, you can measure the length. So L is the length of the line, lambda is the wavelength, which is in meter, length is also in meter, lambda dash is effective wavelength, which is also in meter, n is number of full wavelengths, and P is length of fractional part. Okay, so if you know number of wavelengths and if there is any partial or fractional wavelength, and if you know, and if you can measure the length of that fractional wavelength, okay, that part, this part is the fractional wavelength. So if you can measure the length of fractional wavelength, you can measure the distance, the length between first point to last point, that is the length between 2 points. So we have the device, EDM instrument, electronic distance measurement instrument. It emits a pulse or a wave which travels from the instrument to the reflector. Okay, so we have kept the instrument at point A and we have kept the reflector at point B, and we want to measure the distance from point A to point B. So the instrument which is kept at point A will emit a wave. Okay, that wave travels through air, hits the reflector, and it comes back to the instrument. That's why the time measured will in the time that is measured, the wave travels distance 2 times. That's why time is t by 2. Okay, so or we can measure the number of wavelengths, that is how many lambdas are there, and we can also measure the fractional part of the lambda. To find the length between A and B. So these are the two methods by which we can measure the distance between 2 points using electronic distance measurement instrument. So this is the basic principle of electronic distance measurement. We'll move to the next topic, that is ranging. Now, when you are measuring the length of a survey line, the chain or tape must be stretched straight along the line joining its two terminal points. If the length of the line is less than the length of the chain, there will be no difficulty. However, if the length of the line exceeds length of the chain, some intermediate points will have to be established in line with the two terminal points before the chaining is started. Now this process of fixing or establishing such intermediate points is known as ranging. Ranging is very important in surveying. Okay, in surveying we are always establishing lines. The first method of ranging is direct ranging. Direct ranging is done when 2 points are nearby, and the distance between 2 points are less than the length of the tape. Okay, so I'll just give an example. Let's say we have a line. Let the line be let the length the survey line be denoted as AB, capital A B. So consider a survey line A B. Starting point of the line is A, end point of the line is B. So we have a survey line AB, and we have a tape or a chain. We have a tape or a chain now whose length is 20 meters. Now the red color line indicates the tape. Now the length of the tape is more than length of the survey line AB. So you can easily measure distance between any 2 points on the survey line AB by using the 20 meter tape. or chain. Now let us consider one more survey line. Now let's say this survey line, let it be denoted as CD. Now let this survey line, the length of this survey line be more than 20 meters. That is, let the length of survey line be greater than the length of your tape. So in the first case, length of the tape is greater than length of the survey line. Now let us come to the second case where the length of survey line is blue color, length of survey line is more than length of the tape. Now I'll denote this survey line as CD. Now if I want to measure distance between any 2 points on CD, let's say I have point C and I have point D, and I want to range a straight line between these 2 points, or measure distance between C and D. Now the tape is smaller than length of CD, so I cannot hold one end of the tape at C and other end of the tape at D. I cannot calculate the distance like that. So I have to hold the tape many times in between C and D to measure the total length of C and D. But I don't know if I'll end up at D. So if I do not measure the length correctly, the measurement will be wrong. It won't be straight, but it will be okay, the alignment will be wrong, and I will not get the distance between C and D, but I will get distance between C and some other point. So the measurement will be wrong. If I start from C in a straight path, I should end at D. Then only I can measure distance between C and D. To do so, we have to establish a straight line between C and D. So to establish a straight line between C and D, we are doing ranging. So we are doing ranging when the length of the line is more than the length of the tape. So we'll establish points between C and D such that the distance between those points are less than the length of the tape, so that we can easily measure the length of CD. So we'll measure the distance, we'll first establish the points, and then by joining all the points we'll establish a straight line, and we'll hold the tape along that straight line, and we'll measure the distance between C and D. So now I am establishing all the points between C and D such that all those points will lie on a straight line between C and D. Now I can take my tape and I can hold it along the straight line, and I can easily measure the distance between point C and D. So that's why we require ranging. When the length of the survey line exceeds the length of the tape and we want to measure the length between those 2 points, okay, so we have to establish some intermediate points so that we can establish a straight line between the terminal points, and we can measure the distance along a straight line. Now there are 2 types of ranging: direct ranging and indirect ranging. Now in direct ranging, the terminal points are intervisible, that is point A and point B. We want to range a straight line between point A and point B. So a person standing at point A can see a person standing at point B. So point A and B are intervisible. And ranging rods are established in between so that we can establish a straight line between point A and point B. So we have a person standing at A, and a ranging rod is fixed at A and ranging rod is fixed at B. Now the surveyor standing at A, okay, will instruct another person who is standing at some intermediate point C to fix his ranging rod at point C such that points A, C and B are in a single straight line. Next, the person from A will move to the next point C, and the person from C will move to the next point D. So now the surveyor standing at C will instruct the person standing at D to place his ranging rod such that the ranging rod at C, D and B are in one single straight line. So that's how now A, B, C, D are in single straight line. Now let us see this animation. We have point A and point B. A ranging rod is fixed at point A and another ranging rod is fixed at point B. Now another person comes at another person C comes, and the person at A adjusts the position of ranging rod approximately so that A, C, B are in straight line, and the same is confirmed by the person at B. He also tries to adjust the ranging rod such that ranging rod at A, C and B are in straight line. Now the person from A will move to the next point, that is at station C, and now another person at D is holding a ranging rod and the person C is guiding the ranging rod in between such that C, D, B are in a straight line. Now we can say that A, B, C, D are in one single straight line, and you can easily measure the distance between A and B using a chain. So this is direct ranging, where the distance between A and B can be measured using a chain or a tape. And the points A and B are intervisible. So this is direct ranging. We'll move to next method, that is indirect ranging. Now indirect ranging is also called as reciprocal ranging, and this reciprocal ranging or indirect ranging is done when the two terminal points are not intervisible. That is, the person standing at A cannot see the person standing at B. They cannot see each other. Now this can happen when there is an obstruction like a hill in between. When there is a hill in between point A and B, the person standing at A and B, they cannot see each other because the hill obstructs the view. Hence A and B are not intervisible. Now we'll see with the help of an animation what indirect ranging is. So okay, check.
Let us fix the station A and station B. Station A and B are not intervisible to each other due to interranging high ground. Select two intermediate.
So station A and B are not intervisible to each other. So we'll select two more stations, station C and station D, such that the person standing at A can see the person standing at C and D, and the person standing at B can see the person standing at D and C. So A, C, D are intervisible. B, D, C are, all the 3 points are intervisible, but point A and point B are not intervisible. So first the person standing at B with the reference of person standing at C will guide the person at D such that B, B, D, C are in a straight line. Now we'll move to the other of the line. The person standing at A with the reference of person standing at B will guide the person standing at C to a new position C dash such that A, C dash, D dash are in straight line. Now to the other end, the person standing at D with the help of the person standing at C dash will guide the person standing at D dash to a new position D double dash such that B, D dash and C dash are in single straight line. Next, the surveyor at A with the help of the person standing at D double dash will guide the person at C dash to a new position C double dash such that A, C double dash and D double dash are in a straight line. Now again this process continues. The person standing at B with the help of the person standing at C double dash will guide the person standing at D double dash to a new D triple dash such that B, D and C are in straight line. Now this process is going to continue till A, C, D and B are in a single straight line. So after many trials or iterations we can say that A, C, D, B are in straight lines, and we can measure the distance between A and B with the help of chain or a tape. So this is how indirect ranging is done. So we have a person's in indirect ranging. We have 2 points which are not intervisible to each other, and with the help of two more person, that is person standing at C and person standing at D, we are establishing a straight line between A and B. Now here point A and B are not intervisible but ACD are intervisible and BDC are intervisible. The person standing at A can see the person standing at C and D, but he cannot see the person standing at B. The person standing at B, he can see the person standing at D and C, but he cannot see the person standing at A. So this is how indirect ranging is done. So these are the topics in today's class. We'll just revise today's topics. In today's class, we learnt about how to set up straight lines in the field by ranging of lines. And there are two methods in ranging: direct ranging and indirect ranging. Ranging of lines is done when the length of the survey line, or when the distance between 2 points is more than a length of tape or chain, and direct ranging is done when the terminal points are intervisible to each other. Indirect ranging is done when the terminal points are not intervisible. So this is about ranging, and ranging is very important as we are establishing survey lines, maybe in highway, or when you are constructing a very large structure like dams or very huge buildings. So survey lines are very important when you are doing triangulation survey. That's why ranging is important. The next concept, or the next topic we learned in today's class was electronic distance measurement, which is used in many of the modern surveying instruments like total station, electronic theodolites. It is the fastest way of measuring the distance between 2 points, especially when large distances are involved. So the basic principle is, if you know the velocity of the electromagnetic wave and the time taken by the pulse or the wave to travel from the instrument to the reflector and then back to the instrument, you can easily measure the distance. Velocity is equal to distance by time, and distance is given by velocity multiplied by time. So you can easily measure the distance if you know the velocity of the wave and the time taken by wave to travel from the instrument to reflector and back to the instrument. So that's it for today's class, today's lesson. We'll again meet for the next lesson. So thank you all for attending today's class.